Okay, there was a question regarding drawing the arrows and figuring out the numbers when doing the mechanism problems. So again, this type of problem, really you need to draw the arrow first, and then from the arrows determine the numbers. And the numbers are going to be basically the start and stop of the arrows. So the first thing we're going to look at here is the Swern oxidation. So we have the dimethyl sulfoxide reacting with the oxalochloride to form an intermediate, and it says there's a nucleophilic addition. So you can see from the product that what we've done is form a new oxygen-carbon bond, and we've broken a carbon-oxygen pi bond. So that has to be reflected in the arrows that we push. So the starting arrow is going to start from the oxygen of the DMSO that's bearing the negative charge. And so it's going to attack the carbonyl carbon, and then we're going to break the pi bond. So when we do that, we can see that we start at 6, we attack 2, so we form O to C, and then we break the pi bond 5 to 4. So this would be 6, 2, 5, 4. So now that we've formed this sp3 hybridized tetrahedral intermediate, it's going to undergo an elimination reaction. So again, that's the formation of a pi bond, which we can see, which eliminates chloride anion as the other product. So if we're going to drive the arrow, we're going to start at the oxygen, which is negative. So we start at 8. Oxygen pushes the arrow down to form the pi bond. So we're going to do 8 to 5 because we want to form the pi bond. And then we're going to eliminate the chlorine, so 7 to 6. So we're forming the pi bond, and then the electrons in this sigma bond go on to chlorine, so it gets the negative charge. So we end up with 8, 5, and then 7, 6. So again, the learning tool of this, each arrow has 2 digits, one for the start and one for the end. So we're forming and then breaking a bond. So in the next step, we have the chloride minus, and we can see in the product it's forming a bond to the sulfur, and then we're breaking an existing bond from sulfur to oxygen. So chlorine's going to drive the reaction, negative is attracted to positive, and then we're going to break a sigma bond. So 8 to sulfur is 6, 7 to 4. So 8, 6, 7, 4. So forming a bond, breaking a bond, 8, 6, 7, 4. Now that we have the reactive intermediate, which is this chlorosulfonium ion here, we have the negative charged on this other species, and this decomposes by showing the formation of carbon dioxide and carbon monoxide. So we're looking at how this forms. Let's draw the arrows in. The negative charge drives it. So there we're going to form a CO pi bond. And now what we have to do is break the bond, a sigma bond between these 2 carbons. So that's going to be 5. Then we need to form a lone pair on that carbon and then eliminate off. So we form Cl minus. So we're actually reporting 6 digits here. So we're going to do 5 to 6 and then 9 to 8. So we have 0, 1, 5, 6, 9, 8. So this forms the pi bond to form CO2. This breaks the bond and gives a lone pair to form carbon monoxide, and then this breaks the CCl sigma bond to form the chloride anion. And then lastly, we're seeing now the activated species where the alcohol has been substituted for the dimethyl sulfide, and this is plus. Now we have the base, which is going to do the elimination. The first arrow is drawn for you, abstracting the hydrogen on the carbonyl-carbon. So now what we need to do is an elimination to actually form the pi bond and remove the activating group. So we continue the arrows in terms of the flow to form the pi bond, and then we're going to break the OS sigma bond. So from that we have 5, 3, 1, 0. So forming the pi bond, breaking the sigma bond. And the product of that is our ketone, and then the dimethyl sulfide. And then we get the conjugate acid of the trimethyl or triethylamine, and notice the plus charge migrates from sulfur to nitrogen. So that completes the Swern oxidation. And then we had one more question about SN2 reaction, in which this negatively charged carbanion is attacking an epoxide, so we have to choose which carbon. So we're going to go for the least substituted carbon because this is an SN2 reaction. So the electrons in this species of the bond reside on the carbon because this is a salt. So we can think of it as Na plus carbon minus, so that drives the arrow. So we form a carbon bond between 7 and 6, and then we're going to break 5 to 2. So form, break, and then so from that we get O minus, and then Na plus is the intermediate that is formed, and then when that's worked up we get the neutral alcohol. So again, keep in mind the key here, odd numbers are on bonds, even numbers are on atoms, and for every arrow, the start and the stop.